Problem 11 states, given the following unidirectional graph, determine the shortest path using Dijkstra algorithm from 4 to 18. So in order to do this, we have to keep track of all the vertices. And we have two things. We're going to have the weight and the parent. And so we started at 4, so the weight will be 0 and the parent will be negated. And then for everything else, we put the current weight as infinity. Now we start at 4, and we look at the outgoing vertices 5 and 20. So 5 has an initial parent of 4 and a weight of 0 plus 1. 20 has a parent 4 and has an initial weight of 0 plus 3. So we get 3 here. Now we create a priority queue and we sort it based on the weights. So we want to evaluate 5 first because 5 has the less weight, and in this particular scope, this is the shortest path. So now let's evaluate 5. 5 has one outgoing edge to the vertex containing the value 10, and that has a value of 4. So this means this path is 1 plus 4, which is 5. And we know this because the current weight at 5 is 4. And since the current weight at 10 is infinity, 1 plus 4 will give us a weight of 5, and a parent with a value of 5 as well. So since the weight is 5 here and 20 is 3, then our new priority queue is going to be 20 and 10. So from 10, we have 2 outgoing vertices. We have an outgoing edge to 10. 3 plus 3 is 6, and the current weight going to 10 is 5. So we don't want to do this. 20 has another outgoing edge to 30. 3 plus 2 is 5, and 30's current weight is infinity, so we're going to say its parent is 20 with a weight of 5. And so now we had 10, which is 5, and 18, which is also 5. So right now we're going to have 10 and 18 in the same priority queue. Since 10 was in there first, it'll be at the top. So let's evaluate what goes on outside of 10. 10 has one outgoing edge to 18, and 10's current weight is 5. So therefore, 5 plus 2 is 7. 8's current weight is infinity. So we're going to say that the weight is 7 and the parent is 10. Now we found it, and I apologize, this should be 30, not 18, which would be in the priority queue. And so now let's evaluate 30. 30 has a current weight of 5. It's 5 plus 4, which is 9, and 18's current weight is 7. So therefore, we do not replace that in the priority queue. So now we've evaluated the entire graph and the priority queue is empty. We can now start at 18 and say, well, what's our parent? So it's going to be 18 will be last, and then it'll be 10. 10's parent is 5. 5's parent is 4. So 5, 4, 5, 10, and 18. Therefore, the answer is A.